almost done here. Okay, now we're going from least common multiple to greatest common factor. So now we're talking about factors again, the numbers that we multiply together to get these bigger numbers. So, greatest common factor for 18 and 45. And we're just going to list them out like we did this yesterday, all right? We have 1 and 18. We have 2 times 9. We have 3 times 6. Nothing times 4, nothing times 5. For 45, we have 1 and 45. Nothing times 2 because it's an odd number. 3 and 15. Nothing times 4. 5 times 9. Nothing times 6. Nothing times 7. So, now we're going to go through and find our common factors. We have 1, we have 3, and we have 9. So the greatest common factor for 8 and 15 is 9. So you really need to make sure you're paying attention to what the directions are asking. It's going to ask to find the GCF, or is it asking to find the LCM, least common multiple? Here we're finding greatest common factor. Now we're going to 33 and 66. So for 33, we have 1 and 33. Nothing times 2 because it is an odd number. 3 times 11. Nothing times 4, nothing times 5, nothing times 6, nothing times 7, nothing times 8, nothing times 9, nothing times 10. So those are our factors. For 66, we have 1 and 66. It is an even number, so we can divide it by 2. It would be 2 and 33. 3 and I believe that's going to be 22. Nothing times 4, nothing times 5, nothing times, or 6 and 11 is 66. Nothing times 7, nothing times 8. All right, now, greatest common factor here. We have 1s, we have 3s, we have 11, and we have 33. All right, so our greatest common factor here, GCF, 33. We have one more problem that we're going to look at. And it's our last word problem. And I'm actually going to scoot it up there so we can see it. All right. So Jacob is putting nonfiction, 18 nonfiction, and 30 fiction books on bookshelves. Each shelf will have only fiction or nonfiction, and every shelf will have the same number of books. Same number of books. What is the greatest number of books for each shelf, and how many shelves will there be for each type of book? So, I circled the word greatest because when you see greatest in a word problem, we're dealing with greatest common factor. That's the first thing we need to find. So our numbers are 18 and 30. And we're looking for the greatest common factor. 1 and 18. 2 and 9. 3 and 6. Then we have 1 and 30. We have 2 and 15. We have 3 and 10. Nothing times 4. We have 5 times 6. So let's look at our common factors. 1, 2, 3, 6, and that's it. So our GCF is 6. So that means the greatest number of books that are going to be on each shelf is 6, because the GCF is 6. Now, we're going to take our 18 plus 30, because that's our total number of books in all, equals total books. We have to break down our numbers into multiplication problems, like we did yesterday, using the GCF as one of the factors. So 18 is broken down to 6 times 3. 30 is broken down to 6 times 5. We pull out these 6's. So it's going to be 6 times 3 plus 5, because that's all that's left. So, like I said, the greatest number of books on each shelf is going to be 6. And if you need to, you can draw yourself out a diagram. We could draw out a diagram over here. We have nonfiction and fiction. So for our nonfiction books, to have 18, we're going to need to have 3 shelves of 6. So I'll do N's for nonfiction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's our 18 nonfiction books. For fiction, we have 30. So that means with 6 books in each row, we're going to have 5 shelves. And hopefully I can fit 5 rows down here. So fiction, F, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I can't fit the bottom row. 1, 2, 3, 4, 5, 6. So if you needed to write out a diagram for yourself, that would be what it would need to look like. But to answer the question is, there will be 6 books on each shelf, and we would have 3 shelves of nonfiction and 5 shelves of fiction. All right, so there's our answer for this word problem right here.